Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants. And today we're looking at the properties of oxides. So we're asked to identify each oxide as either acidic, basic, or amphoteric, which means it lays somewhere in between acidic and basic. So let's take a look at each of these on our periodic table. We've got potassium oxide, which basically what you want to do whenever you're identifying oxides is you want to take each instance that is the item that is connected to the oxygen and look at where it lays on the periodic table. So we have potassium right over here, and so it's considered an alkali metal. Because it is an alkali metal, it would be considered a basic oxide. If it's an alkali metal or an alkaline earth metal, it's going to be a basic oxide. So, basic. Let's take a look at the next one. We've got aluminum oxide. So, coming back over here, let's look for aluminum. So right over here. And aluminum is an interesting thing. It reacts with and acts as both as a base with hydrochloric acid and an acid with NaOH. And because it acts as both an acid and a base in different instances, we classify it as amphoteric. So this one's going to be amphoteric. The last one we have is diphosphorus tetroxide, which means that we have to find phosphorus on our periodic table. Phosphorus is all the way over here. Notice, so it's considered a non-metal. Non-metal oxides are always acidic, or usually acidic. So we're going to call this one acidic. Now, you may be wondering how I came to these conclusions very quickly. Well, it's just a matter of reading the chapter. If you take the time to read the chapter and note the trends on the periodic table for your oxides and which ones react acidically, which ones are basic, those ones are easy enough. Your basic ones right over here. When they're attached to an oxygen, it's basic. Your acidic ones right over here. When they're attached to an oxygen, it's acidic. The tricky ones are over here. Sometimes they're acidic, sometimes they're basic. They could be amphoteric, depending on the scenario. So the amphoteric ones are probably the most difficult to assess readily. And in your metals and such, they could generally be considered basic, or they could be considered acidic, some of them. So, the amphoteric is what's going to cause the most headache in trying to figure out. But if you see a non-metal attached with an oxygen, it's going to be acidic, generally speaking. If you see an alkali metal or an alkaline earth metal, then it's going to be generally basic. So keep those trends in mind, and you won't have any issue identifying the properties of oxides. I highly encourage you, if you've gotten this far on the videos, that you study the trends of the periodic table in this chapter. There are many different trends, such as electronegativity and metallic character and all sorts of different trends. And it's important to understand pretty much all of them. So you want to take the time to just take a look and see what trends you can find with regard to the periodic table. The nice thing about it is that a lot of them will line up with each other, so that you can identify that, electronegativity is this certain trend, but it's just the opposite when you're looking at atomic radius. So knowing those two things, you could say, well, if something's really small, it's also very electronegative. That also makes a lot of sense when you think about it, because that particular atom is holding together its electrons very close to itself if it's small. So that would mean that it would be also very electronegative. It would attract electrons very readily. So knowing these kinds of things, knowing what you can find in terms of periodic trends is very important, and it will show up again and again in future classes and in future lessons.